friends, I welcome you all in this session. As you are aware, in previous session we were discussing about multiple regression, wherein one of the independent variables was categorical, right. So, let us look at one more example. So, we know that the repair time is a function of service since last or the time since last service, okay. And we did find out a regression equation, but it is not the month since last service affects the repair time, but you need to consider what type of work it is, whether it is electrical work or mechanical work. So, this dummy variable or this independent categorical variable also affects repair time. So, we have got a dummy variable here, it has got two levels, right, two levels, mechanical work and electrical work. So, you can have 3, 4, 5, 6, 7, 8 different levels, right. So, let us consider this dummy variable into account and see how regression equation looks like. So, this is the output when you take dummy variable as one of the independent variables, right. So, the adjusted R square is 81%, approximately 82%, then the model is significant. You can see here the intercept coefficient is this. So, y is equal to 0.9305 plus 0.3876 month since last service, right, plus 1.26 dummy variable, right, this is our dummy variable. So, now dummy variable, what we have done here is, if it is electrical work we are coding it as 1, otherwise it is 0, right. So, if we put over here 1, it means electrical work. So, electrical work will take this much more time, is not it, compared to mechanical work. So, this is our equation, right. So, just see this 0.93 1.26 into 1 electrical work, 0.39 into month since last service plus 1.26 into 0, right. So, if it is let us say mechanical work, we will not include this particular part of the equation. If it is electrical work, this would automatically become 0, right. So, at the end of the day you can solve this equation and it comes out to be it is 2.16 plus 2.16 plus 0.38 months since last service, right. So, what I am trying to say is that you need to consider categorical variables because they also affect dependent variable. Same equation, in fact, if you look at these two equations, you can solve in fact this question just like any other multiple regression equation. So, you will have a dependent variable. So, these two are independent variables, right. So, C2 is just this month since last service and this is your categorical variable 1.26, right. Now, this can be either 0 or 1. So, let us solve this question using multiple regression and taking C1 means x1 and x2 as independent variables. So, first we will solve it, right. Let us see what was the output, right. So, here you have got your time, repair time, month since last service, right, and your type of work, whether it is, you just write it dummy, right. Okay. So, just enter the repair time is 2.93, 4.8, 1.8, 2.9, 4.9, 4.2, 4.8, 4.4 and 4.5. Month since last service. Now dummy variable, just go up, this is second number value, you need to go up, yeah, 1, 0. So, 1 is electrical work, right, and 0 is mechanical work. So, first of all we will solve this question as we will take this this variable as a regular predictor or regular independent variable. Regular means metric, right. So, let us go to regression fit regression models. So, response is time, right, and we will take both of these as continuous predictor, month since last service and dummy, yeah, okay. So, this is your output, right, just go down, yeah. So, this what is your answer. So, let us check whether we were getting it's 0.38 and 1.2, just see it's the same answer we are getting, right, 0.93, 0.38, 1.26 into dummy variable, right. But this is not the appropriate way of doing this question. In fact, we need to take this variable as a categorical variable, not as a metric variable. So, what you should do is, we will go back to stat, in fact you can delete this one first, okay. Now, stat regression fit regression model, and this dummy variable, in fact that should come over here, categorical predictor, it is a categorical predictor, right. Okay. Now, this is the correct answer. So, look at this. So, the time, repair time, if it is, let us say, if it is electrical work, then you just enter month since last service over here. Let's take this value as 10 for example, month since last service. So, this becomes 3.8. So, 3.8 plus 2.2 almost 6, isn't it? But if it is, let us say, mechanical work, then what will happen, and this is 10 again, right. So, this 3.8, so it is approximately 4.7. So, that is the difference. So, the total time required, total repair time required is a function of categorical independent variable as well. It is not only the metric independent variable, right. So, this is how you should solve a question wherein you are given dummy activity or dummy independent variable. In fact, it is not the dummy independent variable, the independent variable is categorized as dummy variable, right. So, let us look at solution. This is what the solution we obtained, isn't it. So, repair time is it is this if it is mechanical work, otherwise this if it is electrical work, right. Let us look at one more interesting question. In a company there are salesmen and saleswomen. So, saleswomen are complaining that they are getting lower salary compared to salesmen. So, they are complaining that there is a gender discrimination, and because of that saleswomen are getting less salary compared to salesmen. So, this is the question, and the management decided to collect data on the on their salaries, right, and number of months for which these people are working in the organization. So, months employed for men and their salaries, months employed for women and their salaries, right. So, the question is, do women gets less salary, or do you think that women are being discriminated on the basis of gender? So, that is the question. Now, how to proceed for this question? The first thing which should come to your mind is that you should compare the means of these two, right, means of their salaries, right. Let us look at and let us try to solve this question by comparing their salaries. So, what we will say initially, that mu 1 is the salary of man, mu 2 is mean of salary of woman, right. So, initially we will say that they are one and the same thing, and we will say that there is no gender discrimination in null hypothesis. Alternative hypothesis, men get more salary than women, right. So, it is an upper tail test, right, it is a one tail upper tail test, right. So, let us solve this question using our regular process, calculate pool variance, calculate t statistics, and then this is what is your t statistics you will be getting somewhere here anyway. So, this is what is your calculated t statistics, and the t value from table is this, right. So, this is 2.98, 2.998, this point is this 2.998, and this is 0.92, which is what you have calculated, right. So, you are not rejecting null hypothesis, is not it. So, you do not reject null hypothesis, right. When you do not reject null hypothesis, it means they are same, is not it. So, this is one way of solving this question, but the point is, in this method we have not considered gender or the independent variable which has got two levels, man and woman, right. So, let us move on to this question once again. So, let us find out what is the in fact, this is the output of this question using Minitab. In fact, you can get, so p value is when you test this hypothesis at let us say 90% significance level. So, this is 0.01, right. So, this value is more than 0.01. So, we will not reject null hypothesis. In fact, you can solve this question using Minitab. Let us solve this question using Minitab. So, we will enter salaries of man and woman, right. So, man and woman salary, right. So, 7.5, 8.6, 9.1, 10.3, 13, 6.2, 8.7, and like this you are supposed to enter remaining values, right. So, we will go to stat, we will go to basic statistics, then it is a two sample means test, right. So, this is the one. So, both samples are in not in one column, but we are having in two different columns, right. So, this is sample 1, yeah, one column. So, men sample 1, just select this. Similarly, for woman salary options, this at 99% significance level. So, this is your alternative hypothesis has to be greater than type, right. This is greater than type, okay, yeah. So, this p value is 0.190, right. This is what I have shown over here, it is 0.195, right. Okay. So, we will reject null hypothesis, right, and we will say that there is no discrimination based on gender, or their salaries are same or equal, right. Now, let us look at one more approach to this question. Let us find out relationship between months employed and salary. So, generally we say that the higher the salary if the months employed are more, right. So, higher the months of employment, higher the salary, right. So, you can have this as a dependent variable and this is as independent variable. Okay. And when you plot months and salaries, you can find out these points. So, there are total 9 points, right. So, 5 for men and 4 for women, right. So, if you look at these points, then you should just see this. This is the salary of men, all these points, and this is, these points are salary of women. Now, this plot tells you many things, isn't it? So, you can see that there is some difference, right. Just scatter plot is giving you some information that there is something wrong, they are not same, right. So, what you are doing is, let us find out the effect of months employed on salary. So, you can just do it for these two variables, dependent variable salary and independent variable months employed, right. Okay. So, we will just solve this question. So, this salary now, okay. We will can delete these columns. No, in fact, you have just so these are salaries now for women, this months employed, right. So, 6 point, yeah, 6, 10. So, you just enter all these data as far as months employees are concerned. We will have just regression equation. So, regression. So, salary is dependent variable or response, right. So, C2 is response and C1 is continuous predictor, right. Okay. So, this is 5.8, this is the equation, right. So, this is the estimation line which you can see here, right, 5.8 and 2.233 months employed, right. R square 92.6 here as well, R square 92.6, right, this value. Okay. Now, if you look at the table of residuals for this question, then you need to look at residuals. Let us find out residuals for this question. So, this is your equation 5.8 plus 0.23 months employed. If you put, let us say, independent variable 6 over here, right, months employed 6, because this is the months employed. So, when months employed is 6, months employed is 6. This is your estimated value or y hat value, it is 7.2, right. So, this is what is your fitted value, right, 7.2. Similarly, if you put, let us say in this equation instead of 6, if you put 10, right. So, that would be the fitted value, right, 8.1. Now, you need to find out residual, which is difference of these two. So, 7.5 minus this is this, 8.6 minus this is this. So, these are residuals. If you look at residuals, then all these are positive and all these are almost all these are negative. So, there is a pattern. So, residuals are not randomly distributed, right. So, this is a special observation in residual, right. So, it means there is something is missing in this question, right. So, that can now be further analyzed. We will take gender as one of the independent variables, right. So, months employed, gender, and let us call all these minus 0 or give them as code equal to 0 and 2 women 1, right. It is up to you, you can have 1 over here and 0 over here, there will not be any change in the solution except the sign of the coefficient, right. So, let us look at the solution to this part of the question. So, this is how you can again rewrite equations. So, for salesman this x 2 is equal to 0, right, we are taking x 2 is equal to 0, and for woman x 2 is equal to 1, right. So, this is the final equation for salesman, this final equation for saleswoman, right. So, let us now reframe null hypothesis, and we will say that let us say if in this equation if this is negative, the coefficient of B2 is negative, it means because this is a coefficient for woman, right, for independent variable x2, not for woman, right. So, initially we will say that this is 0, the moment we say it is 0, it means x2 is whether it's man or woman, it is not affecting the salary, right. But if B2 is negative, it means women are getting less salary. Okay. So, let us solve this question, and when we solve this question we will get this output. So, let us solve this question using Minitab. Yeah. So, you can do coding over here. So, this is for a man, this is for woman, right. So, regression, fitted line, yeah. So, initially, yeah, so salary is of course month is this, in fact we will take this code as here only, let us take code as continuous predictor for the time being, okay. Yeah. So, this is the answer, right. So, you are getting this B value as -1, right. It means there is a discrimination taking place against women, right. So, 6.24, 0.22 and 0.789, this is what the answer we were getting here, right, is not it. But let us look at the other way, wherein we will take this independent variable as a categorical independent variable. So, we will go to fit regression model. So, this code is now rather than this we will put it categorical predictor, right. So, this is the code now. We have said that month since last employed, if I take it for example 10, right. So, So, this becomes 2.27 and this is 6.24. So, it is total, it is 9, right. Salary is 9, but if it is, if it's woman, right, then if this is 10, then this is 2.27, then it is 2.27, 6, 8. So, salary would be 8 and in this case it would be 9. So, there is a clear cut case of discrimination against women as far as salaries are concerned, right. So, this is the right way of solving question if you have got a coded independent variable, right. So, let us look at one more question. So, in this case the final decision which we will take is that firm does discriminate against its women employees, right. Now, let us look at one more case of modeling of regression. It's called transforming variables and fitting curves. So, let us say you are receiving raw materials from your vendors, you are manufacturing something and you receive raw material in terms of batches. So, in different batch sizes, right. So, when batch size is 100, you always get 5 defectives, right. So, you have collected data over about batch size and number of defectives. So, you want to know is there any relationship between batch size and number of defectives. So, first of all you should draw a scatter plot. This is your scatter plot, is not it. So, you can see over here there is a non-linear relationship, right. So, let us find out this relationship. When you solve this question, this is how your line of estimation or regression equation looks. It is minus 47.9 0.36 into batch size, right. So, if batch size is let us say 1000, right. So, this becomes 367, right, minus 47 point or let it be 48. So, this becomes whatever it is, right. So, that would be the number of defectives. Now, when you look at the residuals for this question, so this is your regression equation what you have calculated. If base size is 100, you know initially in the question itself when base size is 100, let us find out what is its fitted value. So, fitted value is this one, okay. So, and this was your number of defectives 5. So, 5 minus this becomes 16.9. So, this is first residual. Similarly, if you put the second independent variable which is what 125. So, when you put 125 you will get some value over here and then number of defective minus that value, this would be the second residual and so on. So, this first, second, third, so this is the last residual, right. So, if you look at these residuals carefully, you will find that all these are positive, negative, one positive, then all these are negative, just see, yeah, in fact up to this point these many negative and these positives, right. So, there is a pattern of residuals, some of them are positive, some of them are negative, they are not randomly distributed, it means there is some problem with the model, right. So, what we try to do is just by looking at this plot, we will say that this is not a linear relationship, this is a non-linear relationship. So, what we do, we will take the square of base size which is our independent variable. So, 100 square is equal to this 10,000, this square is equal to this and so on, right. So, let us now run a regression between number of defective, base size and base size square. So, this is with base size square. So, this is R square, or let us look at adjusted R square. So, 99.3 is the model fit. Earlier what it was, when we did not take square, it was 95%, right. Now it is 99%. Just see how much improvement has taken place in the model, right. So, if you take let us say base size square and base size both, then what happens? This is 99.5, earlier it was 99.3. So, this is even a better model. So, you can fit a model depending upon the values of independent and dependent variables. With this we come to an end of this particular course. Whatever syllabus which was designed for this course, with this lecture I am completing the last topic. If you have got any questions or queries, you can always approach me. Thank you.